Alright, so this is the last of our basic information that we need to know before we get into operations with fractions. In this section, we're going to talk about writing fractions in lowest terms. This comes from section 2.4 of the textbook. So in this section, the thing that we want to focus on is something called a common factor. A common factor is a number that divides into a list of numbers. Our goal is to find the greatest common factor. And the greatest common factor is the largest number that divides into a list of numbers. Now in the previous section, we did two things with factors. The first one was listing out all the factors, and that's going to be the first way that we can find the greatest common factor. So let's look at some examples. Example A, I want to list out all of the factors for 6 and for 12. So 6, we have 1 and 6. 6 is also divisible by 2, and if you divide 6 by 2, you get 3. These are all the factors for 6. For 12, we have 1 and 12, 2 and 6, 3 and 4. So now common factors. I want to know all of the numbers that appear in both lists. We have 1, 2, 3, and 6. Now our GCF is the largest of these numbers, and so our GCF is going to be 6. Let's try a couple more examples. Let's look at example B. Example B, same thing. I'm going to start with 32. We get 1 and 32. 32 is divisible by 2, and we get 16. It is not divisible by 3, but it is divisible by 4. We get 4 and 8. 64. We get 1 and 64. 2 and 32. 4 and 16. And we get 8 times 8, or just 8. Our common factors, we have 1, 2, 4, 8, 16, and 32. And our greatest common factor, the largest of the common factors, is 32. Okay, a couple more. Let's try 32 and 56. We just finished doing all the factors for 32, so they are still the same. We still have 1 and 32, 2 and 16, 4 and 8. For 56, we have 1 and 56. We have 2 and 28. It's not divisible by 3, so we're going to skip over to 4 and 14. And the last one is 7 and 8. So our common factors are 1, 2, 4, and 8. And our GCF is 8. All right, last example. 75. We have 1 and 75. We have 3 and 25. And we have 5 and 15. For 82, we have 1 and 82. Two and 41. Our common factors, the only number that appears in both lists is 1, and so this is also our GCF is 1. This is not a term that you need to know, but when the largest common factor is 1, we actually refer to this as relatively prime, meaning that they have no common factors other than 1. Okay, so this is one way that you can find common factors and greatest common factor. We can also do the same thing with prime factorization. And so if we go ahead and what we're going to do for this is we want to write each number using prime factorization. And then we're going to put any factors that appear in both numbers in the GCF. We're going to multiply the results, and we have our greatest common factor. Note, if there are no common factors, then the GCF is 1. So let's try some examples using this. If we look at 6 and 12, 6, if we factor it, we get 2 times 3. 12, if we factor 12, get 2 times 6, and 6 factors to 2 times 3. So we get 2 times 2 times 3. Now when I'm looking for GCF, I don't use exponential notation. I like to write it out in expanded form. All right, so what do they have in common? We have a 2, times a 3, and if we multiply this together, we get 6, which is what we got when we talked about using lists. Okay, a couple other ones. B, 32 and 64. So 32, if we factor this, we get 4 times 8. 4 breaks down to 2 times 2. 8 breaks down to 2 times 4. And 4 breaks down to 2 times 2. So 32 is equal to 5 2's being multiplied together. If we do 64, 64 is 8 times 8. We already factored 8 already. This is 2, 2, and 2. Same thing here. We get 2, 2, and 2. And so 64 is equal to 6 2's being multiplied together. So now if we go ahead and find our GCF, we've got 1, 2, 3, 4, 5 2's being multiplied together. And if you multiply that together, you do end up with 32. All right, let's try the 32 and 56. Again, I already know what 32 is equal to. This is 5 2's being multiplied together. 56, if we factor this, this is 8 times 7. And again, I know that 8 is equal to 3 2's. So we get 2 times 2 times 2 times 7. For our GCF, we get 1 2 times 2 times a third 2, and we're done. They don't have anything else in common. And so our GCF, if we multiply 2 times 2 times 2, we get 8. All right, example D. If we factor 75, this is 3 times 25, and 25 is 5 times 5. If I factor 82, I get 2 and 41. And in this case, notice that they have no common factors. So we need to go back to the note that I had up here above. If there are no common factors, then the GCF is 1. Okay, so these are all tools that you can use to help you find greatest common factors and common factors in general. Now, where does this come into play when we talk about fractions? Common factors and greatest common factor comes in when we talk about simplifying fractions. In this section, we want to talk about writing fractions in lowest terms. A fraction is said to be in lowest terms if the GCF for the numerator and the denominator is 1. There are some other phrases that we want to know for lowest terms. Other phrases that you will see is reduced fractions or simplified fraction. So keep an eye out. These mean the same thing. So we're not going to simplify yet. For starters, we just want to determine if the fractions are in lowest terms. So the question is there a common factor to the numerator and denominator other than 1? If there is, then it is not in lowest terms. So let's try some examples. A, 4/5. Is it in lowest terms? The answer is yes. The only number that divides into 4 and 5 is 1. Example B, 6 and 18. 6 over 18. Is this in lowest terms? The answer is no. We have a common factor. And it doesn't matter what you list, there's actually several. You can say 2, 3, or 6. 6 and 18 are both divisible by these numbers. Example C, 9 over 15. Is this in lowest terms? The answer is no. 9 and 15 have a common factor of 3. And finally, 17 over 46. Is this in lowest terms? The answer is yes. 17 and 46 do not have any common factors other than 1. So when we talk about writing fractions in lowest terms, this is going to be the first thing that we want to know, is what is the common factor, or the greatest common factor. So in order to write a fraction in lowest terms, the first thing we're going to do is determine the GCF. That's our goal. If you can find the GCF, you can do this in one step. We want to find the GCF for the numerator and the denominator. What do we do with that number? We're going to divide the top and bottom by the GCF, or the common factor. From there, we want to check, is our new fraction in lowest terms? If it is not, we need to repeat steps 1 and 2. So let's go ahead and look at some examples. Example A, we have 15 over 20. I want to know what is the greatest common factor. The greatest common factor for 15 and 20 is 5. So we're going to divide the top and bottom by 5. When working with fractions, one of the things that we're going to see is that whatever we do to the top, we need to do to the bottom. And that applies to simplifying fractions as well. If we divide the top by 5, we need to divide the bottom by 5. We should end up with 3/4. And 3/4 is a simplified fraction. All right, if we look at example B, what is a number that divides into 24 and 36? The one that I come up with is 6. If we divide 24 and 36 by 6, we get 4 over 6. 4 over 6 is not in lowest terms. We can still divide by 2. If we divide by 2, we get 2/3. Now 6 and 2, these are neither the greatest common factors. And as I said, the goal is to divide by the greatest common factor. That way this can be done in one step. So just to show you that we're still going to get the same answer no matter what, our greatest common factor is actually 12. If we divide top and bottom by 12, we get 2 over 3. And so notice that we do get the same answer no matter what. So the main thing is though the greatest common factor is our goal, just find something that divides into it. It may take you a few more steps, but you will still get to the same answer. All right, let's try example C, 28 and 42. What is a number that goes into 28 and 42? Off the top of my head, I recognize 7 as going into both. And so if we divide by 7, we get 28 divided by 7 is 4, and 42 divided by 7 is 6. Again, this is not in lowest terms, so I do need to go a little bit further. 4 and 6 are both divisible by 2. and we get 2/3. For this one, if you recognize the greatest common factor is actually 14. All right, let's try another example. Let's try example D, 18/90. My greatest common factor here, or the one that I recognize off the top of my head, is I do know that both of these are divisible by 9. And if I divide by 9, I get 2/10. This is not in lowest terms. I can continue dividing. Both of these numbers are divisible by 2. And if we divide by 2, we get 2 divided by 2 is 1/10 divided by 2 is 5. 1/5 is in lowest terms, so we are done here. All right, let's try a couple more. Example E, 60/72. My common factor that I recognize, I think they're both divisible by 12. And so if we divide by 12, 60 goes into 12 5 times. Or 12 goes into 65 times. 12 goes into 72 6 times. 5/6 is a reduced fraction. Finally, example F. What is a number that divides into 16 and 40? I'm going to go with 8 to start off with. And if we divide by 8, we get 16 divided by 8 is 2. And 40 divided by 8 is 5. 2/5 is a reduced fraction. Now, one of the tricks of working with GCF and dividing by common factors is, again, you need to know your multiplication tables in order to be able to recognize numbers that divide into both. Now, if you still struggle with your multiplication tables, there is another method that you can use in order to simplify fractions. What we're going to do is we're going to use prime factorization. So, this is going to allow us to work with just one number at a time. First thing we want to do is we want to write the numerator and denominator using prime factorization. Again, I'm going to write it out in expanded form. I don't want exponents. And then we're going to cancel common factors. From there, we multiply what remains straight across. So let's go ahead and try some examples. Let's start with 60/72. So 60, if I factor this, I get 6 times 10. 6 is 2 times 3. 10 is 2 times 5. I'm going to reorganize it, and I'm going to write it as 2 times 2 times 3 times 5. All right, for 72, if we factor 72, we get 8 times 9. 8 I know is 2 times 2 times 2, and 9 is 3 times 3. So let's go ahead and bring that back up to our fraction. And from there we want to pair them off. So we're going to cancel. I can cancel 2 2s, and I can cancel a 3. All right, so what do we have left on top? I have just a 5. On bottom, I want to multiply my 2 times 3, and I get 6. And that is what we got on the last slide as well. So notice that we get the same answer. All right, let's look at example B. I'm going to start with 162. This is 2 times 81. 81 is 9 times 9. And each of the 9s is 3 times 3. So 162 is equal to all of the numbers circled. We get 2 times 3 times 3 times 3 times 3. All right, 54. What multiplies to 54? I'm going to go with 6 and 9. 6 is equal to 2 times 3, and 9 is equal to 3 times 3. So on the bottom, we're going to have 2 times 3 times 3 times 3. All right, we can now cancel, so I can cancel a 2, and I can cancel 3 3s. Now if we multiply what's left, I have 3 on top. What do I have on bottom? Well, note that when we cancel, we're actually dividing. So 2 divided by 2 is 1, 3 divided by 3 is 1, as is the other 3 divided by 3s. And so what we actually have left over, if everything cancels, you are left with a 1. From here, I can simplify this down to a whole number. 3 divided by 1 is 3. So as you can see, we can use this on some regular fractions. Me personally, I know my multiplication tables really well. And so, but I still bring out the prime factorization when I get to problems that I don't necessarily know how it simplifies. Please note there is a difference between it does not simplify and I don't know how to simplify it. So for instance, on example C, I don't know how this simplifies, mostly because of the 91. I don't know how or if it even factors. So be very careful on problems like this. You don't want to sit there and say it is reduced or it's in lowest terms without actually checking it. So for this problem, I'm going to start with my easy factorization. I know how 35 factors. This is equal to 5 times 7. Now 91 is kind of a gray area for me. As I said, I don't know how it factors or if it factors. And so you can use a trick here. And the trick is, remember the goal. The goal is to simplify the fraction, meaning that if it simplifies, either 5 has to divide into 91 or 7 has to divide into 91. And I know 5 does not divide into 91 because this number ends in 1, therefore it's not divisible by 5. So that means I want to know, is 91 divisible by 7? So let's check it. 7 goes into 9 one time. 1 times 7 is 7. We bring down the 2. We bring down the 1, and 7 goes into 21 3 times. It does divide evenly. So 91 is actually equal to 7 times 13. So I can cancel common factors. And we can go ahead and write what's left over. We get 5 over 13. All right, let's try one more of these. Let's try example D, 74 over 111. I'm going to start with the easier number. For me, 74 is easier. I know that 2 goes into 74. And if we divide 74 by 2, we should get 37. So I want to use these numbers in order to factor 111. 111, I want to know, is it divisible by 2? And the answer is no. So my only way to simplify this fraction is if 111 is divisible by 37. So 37 goes into 111, I think 3 times. Let's try it. 3 times 7 is 21. 3 times 3 is 9, plus 2 is 11. And so it does divide evenly. It goes in 3 times. So 111 is equal to 3 times 37. We can cancel, and we are left with 2/3. So as I said, this method is nice if you struggle with finding common factors. Quite often it can be intimidating working with 2 numbers at a time, and this allows you to work with just 1 number at a time. It is a little bit lengthier, but it does work. Okay, so the last thing we want to talk about is equivalent fractions. Equivalent fractions are fractions that represent the same quantity. Every time that we have simplified the problem, we have said that, for instance, 4 over 8 equals 1/2. Okay, they are equal, and so they are equivalent. So we want to go ahead and determine if the following fractions are equivalent by simplifying them. So let's go ahead and look at some examples. Example A, we have 16 over 48. I want to simplify the fraction. So these numbers are both divisible by 16. And if we divide by 16, we get 1/3. (24 over 72). These two numbers are both divisible by 24. And if we divide top and bottom by 24, we get 1/3. So are they equivalent? Yes, they are. All right, let's try one more. Example B, we have 45 over 60 and 50 over 75. So 45 over 60. Both of these numbers are divisible by 15. And if we divide by 15, we get 3/4. (50 and 75 are both divisible by 25. And if we divide by 25, we get 2/3. 3/4 and 2/3 are simplified fractions. They are in lowest terms. And are they the same? And the answer is no. So these two fractions are not equivalent. Alright, so that takes care of the section for simplifying fractions. This is something that we will use throughout the rest of our module. When we want our final answer, we always want our final answer to be in lowest terms. And so this will always be at least the last step on each problem. Alright, so go ahead, take a quick break, and then I will see you again shortly. The next thing we're going to get into is multiplying and dividing fractions and mixed numbers.